All right, so this problem reads, semi-trailer trucks have an odometer on one hub of a trailer wheel. The hub is weighted so that it does not rotate, but it does contain gears to count the number of wheel revolutions. It then calculates the distance traveled. If the wheel has a diameter of 1.15 meters and goes through 200,000 rotations, how many kilometers should the odometer read? All right, so we know that the diameter is equal to 1.15 meters. Now, if we have a wheel, that is, of course, the diameter of the wheel. If the wheel rotates, one revolution of the wheel corresponds to the distance of one circumference of that circle. You can imagine if we start at that location and we roll through a single revolution, the wheel has traveled around its circumference in linear distance. And so we know that one revolution is the distance of one circumference. All right? So if the diameter is 1.15 meters, the circumference is equal to pi times the diameter. So that is equal to 3.61 meters. So for every revolution, the truck will move forward 3.61 meters. Okay, so how many revolutions is in one radian? We want to know how many kilometers. So we have 3.61 meters per revolution, and we know that that truck, we are told it makes 200,000 revolutions. So if it makes 200,000 revolutions, it goes 722,566 meters, which is 722 kilometers. All right, so in one revolution, we go 3.61 meters. That's the circumference of that circle. And so in 200,000 revolutions, we go 722 kilometers. Now that's actually not the only way one can do this problem. We can do it another way. We can use our concepts of angular distance. We know that the radius, the distance an object travels, is equal to the radius times the angle through which that object travels. Okay, and this angle is in radians. So how many radians is 200,000 revolutions? Well, that's going to use that relationship. 200,000 revolutions. In one revolution, we go through 2 pi radians. So 200,000 revolutions, put that in, 200,000 revolutions times 2 times pi gives us, oh goodness, I can't even read it, 1256637 radians. 1256637 radians. All right, so how far is that distance? Well, my radius is half my diameter. 1.15 divided by 2 is so the radius is equal to 0.575 meters. So 0.575 times 1256637 radians is equal to, times, it should be the same, 1256637, 722,566 or 722 kilometers. So, as expected, we should get the same value, but kind of thinking about it in two different ways, but those are related. We get that idea of that circumference from the relationship of our distance is equal to the radius times the angle. Okay, good job.